Jumlah penderita TBC di Jawa Timur tahun ini mengalami peningkatan.
Pemirsa, Indonesia menjadi negara kedua di dunia dengan jumlah kasus tuberkulosis terbanyak.
Kasus 11 kematian per jam.
Tuberculosis remains a significant global health problem, particularly in developing countries like Indonesia. According to the World Health Organization's Global Tuberculosis Report 2023, Indonesia has the second highest number of tuberculosis cases worldwide. A major challenge in tuberculosis control is the rise of multi-drug resistant tuberculosis, which is resistant to common antibiotics like isoniazid and rifampicin. This highlights the urgent need for new, effective treatments with safer side effects.
With increasing resistance, the search for effective and safer alternative treatments is more crucial than ever. One promising approach is exploring bioactive compounds from medicinal plants traditionally used in Indonesia. The country's rich biodiversity offers numerous natural compounds that could be developed as new anti-tuberculosis agents. Hi, allow us to introduce ourselves. My name is Ana Sofia Liz.
And my name is Cherillynn Ilysha. In this study, we conducted in silico analysis through molecular docking to evaluate the potential of secondary metabolites from local Indonesian plants as inhibitors of the enzymes DHFR and RB2671 in the folate pathway.
To perform this experiment, we first downloaded the enzyme structures for DHFR and RB2671 from the protein databank in PDB format. Using Autodoc tools, we separated the ligands bound to these enzymes, saved them as individual PDB files, and prepared the receptor by removing any bound ligands. Both receptors and ligands were converted into PDB-QT format for docking.
Next, we downloaded additional target ligands from PubChem, converted them from SDF to PDB-QT using a SMAS translator, and created a configuration file specifying key parameters like receptor and ligand paths, grid box dimensions, and output locations. All the prepared files, including the Autodoc VINA executable, were organized into one folder for smooth processing. We then used command prompt to initiate docking and validated the results by calculating the RMSD. By superimposing the original and redocked ligands in Autodoc tools, we assessed how well they aligned.
Finally, we analyzed binding affinities from the docking output, tested Lipinski's rule of 5 using SCF Bio, and used PreAmiLab 3.0 to evaluate the pharmacokinetic properties of the ligands. This approach ensured the ligands were both effective and drug-like. We repeated the process for each ligand, testing their potential as enzyme inhibitors.
Based on the molecular docking results of the 23 secondary metabolites, the 5 best candidates were chosen based on their highly negative Gibbs free energy results. These candidates include isoandrografolite, neoandrografolite, berberin, rasparin, and mangostin. These compounds have demonstrated strong binding interactions and pharmacokinetic compatibility. Specifically, their moderate molecular weight, optimal hydrogen bonding, and suitable lipophilicity make them ideal candidates for oral drug development. Based on the graph, the ligand berberin has the most favorable binding energy at approximately -9 kilocalories per mole, indicating the strongest interaction. Among the other candidates, mangostin exhibits the second most negative Gibbs free energy, slightly less negative compared to berberin. All 3 candidates have more negative Gibbs free energy than the reference ligand, TOP. This indicates stronger and more stable bonding with the enzyme RB2671. Therefore, all 3 candidates are potential drug candidates for tuberculosis based on their Gibbs free energy if reviewed further. On the other hand, among the ligands that were analyzed, neoandrografolite had the most favorable Gibbs free energy value, which is at -9.8 kilocalories per mole, indicating the strongest and most sustained interaction with the enzyme. Both rasparin and the natural ligand dihydrofolic acid had the same Gibbs free energy values of -8.8 kilocalories per mole, suggesting similar degrees of binding stability and effectiveness as potential inhibitors. Mangostin exhibits a strong binding affinity as well, although slightly weaker than that of neoandrografolite, with a comparatively less negative Gibbs free energy of -9.4 kilocalories per mole. In comparison, the reference ligand, methotrexate, exhibits the weakest interaction of all the ligands analyzed, with the lowest negative Gibbs free energy of -8.7 kilocalories per mole. These results demonstrate that a number of the ligands had binding affinities higher than those of the reference ligand MTX, indicating that they may be more powerful inhibitors.
The CACO2 permeability test evaluates how well compounds cross intestinal barriers, with values greater than -5.15 indicating high permeability. Isoandrographolite, berberine, and mangosteen show strong absorption potential, making them optimal for oral drug development. Neoandrographolite and reserpine face absorption challenges. Volume of distribution indicates how widely a drug is distributed in the body. Berberine, reserpine, and mangosteen show high VDSS values of more than 1 liter per kg, implying strong tissue affinity, while neoandrographolite is confined to the bloodstream with minimal tissue penetration, shown by its low VDSS value. Human liver microsome, or HLM stability, measures metabolic stability. Berberine and mangosteen exhibit high stability, with HLM more than 30 minutes, while neoandrographolite is less stable, with HLM less than or equal to 30 minutes. The MS test assesses mutagenic potential. Mangosteen, isoandrographolite, and neoandrographolite suggest higher genotoxicity risks, while berberine and reserpine pose lower genetic damage risks. LD50 measures toxicity. MTX and neoandrographolite are highly toxic, with an LD50 of less than or equal to 5 mg per kg, while isoandrographolite and mangosteen are less toxic, with LD50 in between 300 and 2000 mg per kilogram. Trimethoprim is the least toxic. Overall, berberine and mangosteen emerge as promising candidates due to their strong absorption, favorable distribution, metabolic stability, low genotoxicity, and manageable toxicity profile.